Building information modeling has been adopted and introduced in construction industry. This presentation will discuss on the extended use of BIM in construction. We will discuss about 3D printing with its application, benefits, challenges, and recommendations. BIM is a representation which is digital and computable. It has physical and functional characteristics of any built objects, facilities, and related project lifecycle information. It also facilitates exchange and interoperability of the information. Extended use of BIM aims at enhancing and improving the construction project in aspects of cost, time, and quality. It's also concerned about the construction safety, sustainability, lifecycle costs, and ensured workability with innovative designs. 3D printing, VR reality, mobile car application, and green design are some examples of extended use of BIM. We are now focusing on one of the extended use, 3D printing. Under BIM, there are different dimensions from 2D to 6D. 3D are related to multiple views, while 2D is only two pane views. Actually, 3D printing history can go back further than you may realize. There are attempts in 1860s to make three-dimensional sculpture from cameras, about producing photographical maps. In 1961, the Goya Institute published the first weapon prototyping system. In 1984, Charles invented stereolithography, which used photopolymerization to link chains of molecules by light and form polymers and 3D solid. Then in 1991, a fused deposition modeling machine introduced by using plastic to deposit layers. In 1992, a machine called selective laser scissoring machine produced with the use of powder and laser. Afterwards, Rice printer and 3D inkjet printer are also produced in 1994 and 2000 respectively.
3D printing can be used to fabricate the buildings or construction components, such as cladding, structural panels, and columns. It can be carried out on-site or off-site fabrication by using the industrial robots or gallery systems. In the following slide, I will talk about two examples of 3D printed construction. 3D printed footbridge in the world was built in Spain, which has a total length of 12 meters and a width of 1.75 meters. It is made up of 9 separated 3D printed parts and constructed with concrete powder micro-reinforced with thermoplastic polypropylene. This bridge reflects the complexity of nature's form, which allows to optimize the distribution of materials and minimize the amount of waste by recycling the raw material during manufacture. This 3D printed office building is built in Dubai. It only took 17 days to print and was installed on site in 2 days, which significantly faster compared to traditional construction method. The entire cost of the project was only spent $114,000. It was constructed using a special mixture of cement and the building materials decided and made in the UAE and US. It was given an R-shape for safety purposes and to ensure stability.
Now I will introduce the benefits and challenges of BIM in 3D printing. When BIM extends to 3D printing in construction work, it would contribute to the construction industry comprehensively. First of all, using 3D printing could obtain the environmental friendly process, as the printed products only use as much material as needed to form them. This means fewer resources are required and less waste is generated. Secondly, the 3D printing could lower the cost. Compared with the traditional construction method, the cost of 3D printing construction component is much lower, even though the transportation cost of the printer would be high as the size of the printers is currently needed for construction. It also benefits to reduce the cost of material transportation and storage on sites. The cost of customized design could also be lower because it costs the same to create one item as to produce thousands. Reduction of injuries number and fatal on site are also the benefit of the 3D printing. The printers will be able to minimize most of the hazardous and dangerous work such as wet construction process. Besides, 3D printing can be used to produce assemblies that would otherwise need special equipment and precaution to be taken. The conventional technologies may not easy to achieve complicated shape. By using 3D printing, it would have potential to create more efficient and interesting design. Lastly, reducing the building construction time is also possible when using the 3D printing. Even though the 3D printing may contribute a lot to the construction industry, a number of challenges is necessary to overcome. The 3D printer cost will be the limitation of the development of 3D printing. Compared with the conventional construction, the cost will be high. As the technology is still developing, the industry is lacking of people who are familiar with the 3D printing technologies and applications. Although the experimentation is underway for printers capable of using multi-materials, the selection of materials which have been used is limited. To produce more complex assemblies is still complicated. Due to the size limited, the 3D printer will be large. It may be difficult to find the storage area and it will costly to place on site. The printers are currently slow compared to conventional construction, although they can be operated 24 hours a day. On the other hand, someone may worry about the development of 3D printing technology will take jobs from thousands of quality workers.
In this part, we will suggest some new technology for better use of BIM. The first new technology is the radio frequency identification technique and the BIM application. Combine these two technologies, we can create a smart transportation path, which is using the integrated building information system to trace the transportation path of the precast material, and later then use auto-hosting system to transfer the material to the designated area or location. It can reduce the operation time and on-site storage area, as well as to achieve the faster construction cycle. The second technology is the indoor localization system. The BIM application combined with a large amount of sensors and combined with the wireless system and ultra-wideband system to collect the operation data in the existing building. The maintenance professional can base on such information to detect some abnormal condition inside their buildings, and further take response to rectify the defects as soon as they can. It can minimize the nuisance to the building operation and avoid system failure. The next technology is combined with BIM application and robotic device. The construction robot is already exists, and which can replace the human in some dangerous construction trade. It can effectively resolve the labor shortage problems, and also the BIM can provide the database to the robot and further develop the autonomous system. Therefore, the robot can drive the construction independently, just like the AlphaGo. The next technology is combined with the BIM application and cloud computing. The BIM can export the IFC files. It can be saved in the server and downloaded by the portable device. It can achieve the less printing policy and provide the flexible documentation environment to the building professional in the design stage. Also, it can enhance the efficiency in design communication between architect, engineer, and quantity surveyor. Also, it can provide a quickly response in the on-site coordination between construction site and the design office. This is all of our presentation, and thank you.